So thanks for joining. This is a new meetup from the HP developer community team. And today we're going to talk about decoupled policy enforcement with Open Policy Agent, which you might see sometimes as OPA. This is our April meetup, and today I'm very pleased to host Anders, all the way from Stockholm, Sweden, and from companies Styra or Stira. Both are good, I'm told. And he's going to explain about everything about Open Policy Agent. Just before we do that, a couple of points. We have two types of technology talks that we deliver on a monthly basis, both of them. One is called the meetups. That's one of these ones. Here, in May, we'll have an in-depth talks from the Determine AI folks in HP now. And in June, it's not 100% sure yet, because we have also HP Discover, where we are participating, which is causing a lot of work and confusion in the work that we do. So we are looking at trying to get somebody from AWS talking about OpenSearch, but I will confirm that on our calendar page. You should have Denis from our team also posting links in the chat, so you can keep those links, and also you can use later on the chat to ask questions and the Q&A session as well. We have also another type of talks, maybe a little more thought leadership type, which we call Munch and Learn. And this, we have a calendar page for those events. And in May, we are looking to have something around, again, it's candidate for now, but in May, we are looking at something around AG stacks. That stands for agricultural stack. So it's a kind of an open source service around sharing data for agricultural purposes. And we are looking at having a couple of speakers, which should be outstanding. So look at these two pages for not just the next upcoming sessions, but also for all the replay links for these sessions. We also have a couple of other things that I'd like to highlight, which we built. We have a thing that we call workshops on demand, and you can go to this website here to actually see the catalog of those workshops. These are all Jupyter Notebook based, so and they are available on the internet 24/7 for free. And you can get some sort of hands-on experience on a number of subjects. Some are open source, and you'll find that we have added in the past few weeks 5 new workshops on machine learning 101, on Spark 101, one on Docker 101 to get to familiarize yourself with this technology. And I forgot the last one. Yes, the last one is on SpiffAspire integration with Envoy. So take a look at those workshops. You can book them online straight away. Once you book, you have a time slot allocated on one of our server, and you'll be redirected to a Jupyter Notebook with the content of the workshop. We also have more ways to kind of join the community and contribute and amplify the community. You can join our talks, and you can meet us at events. We maintain a calendar of events. We release a monthly newsletter you can sign up to, and you can unregister if you don't like it. We have a dedicated Slack channel for discussing with people around some of the different platforms that we have within HPE or open source projects for which you can develop, with which you can develop, or with which you can integrate. We have a Twitter account with a bunch of followers, already quite like 200,000 people, 200,000 people, yes. And we are welcoming blogs contributions. So if you'd like to give it a try, we have a page called Contribute on our website, which explains how you can submit a blog through a pull request in Markdown, pretty straightforward ways. And also, if you don't like that, you can also submit a draft in Word or in Google Doc. If you'd like to deliver a meetup because you're an expert in a subject, it's also possible. Talk to us, reach out, and we'll look at that. Finally, if you would like to build a workshop on demand that you see is a gap in our catalog, we always welcome a contribution for that too. So we can help you with that. So Lots of ways to join and contribute with the community. So feel free to reach out to us and contribute. With that, I'd like to welcome Anders and hand over to Anders for the rest of the session, and I'll stay quiet.
Thanks, Didier. I really appreciate being here. Let's see if I can share my screen and we can get started. Can you see that now?
Yep.
Awesome. We'll get started then. So, hey, everyone. I'm Anders. I'm a developer advocate at a company called Styra, or Styra, if you prefer the Swedish pronunciation. It's actually a Swedish word, which is a funny coincidence, given I'm Swedish. However, it's an American company. One of the founders was a Finn, kind of brought that word with him, and the domain name was available at the time. So Styra is the founders of the Open Policy Agent, or OPA, as I'm going to refer to it from now on. My background is in software development. I spent several years working with identity systems primarily. So everything around users, asserting identity, tokens, so on and so forth. So that interest kind of brought me into OPA, because for so many years when you're in the identity world, it's all about the user. But what do you do with that data? What do you do with once you have established the identity of the user? Yeah, now what do you use that for? And that's pretty much what authorization is about. But most identity vendors, they don't do authorization; they only do identity. So after a while, I was curious, like what do people do to solve this? And it turned out there wasn't a whole lot of good options. Because in the identity world, you have all these standards. You have OAuth, you have OpenID Connect, so on. You have all these standards for certificates and so on. In the authorization world, there was pretty much no standards, or they were ancient standards. So that's how I got interested in OPA. It seemed like they ticked a lot of the requirements I had at the time. And so here I am 3 years later, still working in OPA. And so I've been working both as an end user, OPA, integrating OPA in a large scale environment where we wanted OPA to be kind of to solve authorization for 700 microservices, so a fairly large cluster. When I don't work with OPA, I enjoy cooking, food, and football. And if you have any questions or you want to reach out later, you want to work on some fun OPA project, and let me know about it, you'll find me at pretty much any of these social medias: Twitter, LinkedIn, GitHub, just my first name followed by my last name. So, right, we're not here to talk about me though, we're here to talk about OPA. What problem is OPA solving? Kind of mentioned that in passing before, but the challenge here is really how to manage policy in increasingly distributed, complex, and heterogeneous systems. I mean, this was a problem in the past as well, but I think with the explosion of microservices and distributed systems, it becomes more and more important that we know like what's going on in these systems and how do we regulate and control, govern what should be allowed or what should not be allowed. That's basically what policy is. So we want to manage that in the application stack. We want to manage that wherever we deploy our applications to. And we want to manage that in our cloud infra. And ideally, we'd want to manage policy for our data, for access to data as well. So there's all these wide array of technologies, and pretty much all of them, they have their own way of doing authorization or policy management and so on. So what OPA is trying to do is to unify policy and policy enforcement across this whole stack. So that's basically what OPA is all about. And OPA, the project, it's an open source general purpose policy engine, which means you can use it for anything really. You can think of OPA as sort of as an oracle, where you load in some policy in OPA, and then you can ask OPA questions, and OPA will provide you with answers. So you might say, given that I am a doctor, should I be allowed to read the medical records of this or that patient? Or given that I have this deployment here, should I be able to deploy it to production on a Friday afternoon? And OPA will, based on the policy of that organization, decide if that's a good idea or not, or if it should be allowed or not. So OPA offers a unified tool set and a framework for working with policy. It decouples policy from your application logic. That's a core idea of OPA, really. Pretty much in the same way that you decouple storage from your application and move that into a database. You move policy out from your application logic or business logic, then you move that into OPA. So if you're using OPA for authorization, your application should ideally have no idea of users or roles or permissions, because that's kind of offloaded to OPA, the policy engine. The policies themselves, they're written in a declarative language called Rego. And we'll take a look at that in a bit. I'll give you a little demo on what that looks like and how it works. Since it's a general purpose policy engine, we see use cases pretty much wherever policy applies to, like Kubernetes admission control, microservice authorization, infrastructure policies, data source access management, data source filtering, build and deployment pipelines, yeah, and pretty much whatever you can think of. There's probably an OPA integration there or a possibility of one. It should be mentioned as well that OPA is an open source project. It's a graduated project in the CNCF, together with Kubernetes, Envoy, other prominent projects. We have a lot of contributors, integrations, and so on and so forth. It's really a vibrant community. Adding to OPA itself, there's also a whole bunch of tools like ConfTest, which takes OPA and applies it to a more kind of specific context. In the case of ConfTest, it's OPA basically running for writing policies on files. Gatekeeper, OPA Gatekeeper, is OPA applied to Kubernetes and Kubernetes admission control. There's also editor plugins for both VS Code, IntelliJ, and many others. But of course, OPA itself is not just a hobbyist open source project, but it's used in production by many of the largest corporations, organizations, and so on in the world. And just to sum it up here, before we move on, I like this quote from Kelsey Hightower, where he says, "The Open Policy Agent project is super dope. I finally have a framework that helps me translate written security policies into executable code for every layer of the stack." That's pretty much, that kind of nails it perfectly for me. So if that's what OPA is, or what OPA does, what is OPA and how does it work? And how can OPA integrate with all these technologies? I mean, like most of those were invented long before OPA, and many of them were invented after OPA. So how does it work? The answer to that is what we call the policy decision model, which is a very basic model, which pretty much it has to be in order to work with all these. So the policy decision model works where you have a service, and we have a pretty broad definition of service. Basically means anything where there's a user providing the service with a request. So this could be a microservice, an API gateway. It could be a Kafka broker. It could be a Linux PAM module. Pretty much anywhere a user asks for something, that service can take that request and remodel it somewhat and send that forward to OPA to offload the decision part from the business logic. So examples include things like, should this be allowed or not, which is authorization, of course, just probably the most common use case for OPA, but it could also be things where you don't want to authorize the user, but rather the object about to be created. That's Kubernetes admission control, Terraform policies, and so on. We'll take a look at some examples later. But the basics remain the same, no matter the integration. You have the service reaching out to OPA, commonly done over the OPA REST API. And it does, the policy input is just JSON. So you have some data, maybe you have a username, some roles, maybe you have an endpoint that the user is trying to query, and you send it over to OPA. And OPA determines, based on the policy it has and any potential data, which could be loaded from any data source. It could be things like calendar dates, could be, I don't know, weather data, it could be permissions, and so on. So it takes all this that it knows, and it makes a decision based on that. And the policy decision that is sent back is also just JSON. So any service which has an HTTP client and understands JSON can be either retrofitted or designed to work with OPA. As for deployment, OPA itself is single executable, a lightweight one. So the ideal deployment model, since OPA is lightweight, you normally want to run OPA as close to the service who's asking OPA for decision as possible. And of course, since every request is going to be piped via OPA, you'd want this to be fast. So you want to minimize latency. And the way you best do that is commonly to run OPA on the same host. In the Kubernetes world, that would be what we call the sidecar model, where two containers run inside the same pod and they can reference or connect to each other via the localhost interface. If you have a Go application, OPA itself is written in Go, so you can integrate via an API rather than over the network. There's also plugins or extensions for Envoy, Istio to integrate OPA in a service mesh. Finally, there's also an option to compile your policies into WebAssembly, so you can run OPA or policy evaluation anywhere you have a WebAssembly runtime. So as for the policies then, what do they look like? They are written in a declarative high-level language, which is called Rego. One of the key ideas, core ideas behind Rego is that a policy should mirror a real-world policy. And what is a real-world policy then? It's basically a set of rules. So a policy in Rego is also a set of rules. And when you evaluate one of these rules, that's when you get a decision back. And these decisions, they are often Boolean values like true or false. Am I allowed or not? Or is the user allowed or not? But it can be any type of data type available in JSON. So you can return lists, you can return strings, objects, and whatnot. OPA provides a unit test framework, which is another benefit of treating policy as code, is of course that you can use any tool or any benefit you have of treating anything as code is now available as well. So you can run unit tests on your policies. You can work with linters, static analysis, pull requests, code reviews, and whatever else you gain from working with code. It's a well-documented project, so check out the docs if you're interested. And there's also a Rego playground where you can try it out without having OPA installed. So at this point in time, I'm going to drop out of the slides, and I'm going to give you a quick introduction to OPA or Rego and policy offering. So I hope you can all still see my screen here. I'm going to open up an editor, and we have a few requirements here. We're going to simulate a microservice or a service really, where we have users, and we want these users We want to allow anyone to read resources published under the public endpoint. We want to allow anyone authenticated to read resources published under users. And finally, we want to allow authenticated users to modify their own user data, but obviously not data of other users. So that's 3 basic requirements for authorization. What we're going to do now is we're going to translate these requirements into Rego. So let's start there. I'm gonna create a file, a Rego file. I'm just gonna name it policy. Names don't matter much here. And I'm gonna create a package called policy. And the package is similar to a namespace in many other languages. So it's a way of grouping rules under a common name. So, okay, we said we want to allow anyone to read resources published under the public endpoint. And so how do we know then what the endpoint the user is trying to access? Well, that's part of the policy query. So when the query comes into OPA, the service will provide us with some data. In this case, use some data to simulate that. Might look something like this. We have the service provides a request. We see a request method. We see a path, meaning like the path of the request. So /user/Jane. In this case, they were nice enough to pre-process that for us into a list, make it a bit easier to work with. We also see that there's a user here, the user with a name and some roles. So the way we're going to work here, we're going to create our first rule. I'm going to name this rule allow. Seems sensible given that that's what we wanted to achieve here. We want to allow someone given some conditions. So we're going to say allow is equal to true because the result here should be true given some conditions. If, and so we call this a rule and we call this the rule head, basically an inverted if then statement. So instead what we do here is we say then, and then we say if, because that's basically what policy is. It's a set of conditions. So it makes sense to flip the order around here. So we're gonna, inside of the body here, that's where we put all the conditions. So if you put something simple, an assertion that we know is true, if we were to query the allow rule now, we would get back true. Since all the conditions here, we even add more conditions, they're still true. So if we are to query this now, it's going to say OPA eval, which is a command line tool to do this for us. And we're going to say data policy allow. Policy, remember that was the name of the package. Allow was the name of the rule. We're going to see that now the rule is true because all the conditions in the body, they were true. If we were to change something here, so that's no longer the case, if we evaluate, we get an undefined. So you might think like, should that not be false? By default, any rule where the body does not evaluate makes the rule not evaluate at all. So if we want to change that to ensure we always return something, we can change the default allow value to false. We try and evaluate that again, and we see now we get false back. So far so good. That's super simple, the anatomy of the rules here. But of course, this was just some silly data. And one thing before we proceed is the evaluator here is going to read these line by line and see if this is true, it's going to move on to the next one. So we're basically doing an and condition here. So if we were to write this in some other language, it might look something like this. And then we'd add more and more conditions. So they're all anded together. And if we are to or something, we want to add more, like the second requirement here. The way we'd solve that is we'd add another allow rule. So if any of these allow rules evaluate to true, we're going to say that the allow rule evaluates to true. But I'm going to go back here to the requirement. We say allow anyone to read resources published under the public endpoint. And we had input data looking like this. So we have a request. So read, that's probably a GET request, right? And the public endpoint would make the input look something like this, I guess. So we're going to just say if the request method is GET, the path or the first path component is equal to public, we're going to want to allow this. So we're going to say input. Input in Rego is a global variable, given that it's such a, it's normally what you work with. So it makes sense that the input is available in all contexts. So we'll just say input request method is equal to GET. If this is true, we're going to move on to the next line where we say path, the first path component. In this case, we don't care for the other. If it's under the public path component, we're just going to go ahead and say that's fine. Anyone should be able to read these. Let's see here. Found it. Oh, that was an old error. So if we go ahead now and evaluate this, given that we have this input, I'm hoping that's going to be true, but it was not. Let's see here. Input request method is equal to GET. The path is equal to public. Is there a typo here somewhere? Oh, sorry. We forgot to include the input. Let's do that then. So, okay, so now we see that given we provided this input, the rule allow evaluated to true, just to make sure we're not doing something bad here. If we change this to put, evaluate again, we see that the decision is changed to false. So, okay, we sorted out the first requirement here. What about the other one? We say allow anyone authenticated to read resources published under users. So again, if we want to add a new condition, an or, so we're not going to add here, we're going to want an or. So we're going to add another allow rule. Since I'm lazy, I'm just going to copy paste this here. We said this was also a read request, meaning a get, a get. In this case, we wanted this to be on the user's endpoint. But the one difference here is that we wanted the user to be authenticated. In this case, I'm just going to say input user. If there is a user object here, I'm going to assume that the user is authenticated. Of course, in a real system, we'd probably use a JSON web token or something more robust to assert the identity of the user. But this works well for the example. So now we have fulfilled the second one here as well. Just allow anyone to read as long as they're authenticated, they should be able to read on the user's endpoint. What about the third one here? Allow authenticated users to modify their own user data, but not that of anyone else. Well, that's kind of sensible. So what might that look like then? We can add another rule. And we say, in this case, modify, that's got to be a put request, right? So if the request method is put and the path is still users, right? We have authenticated users to modify their own user data. So the path is still users. In this case, we said that the path of the user, we have users and we have Yo here. This path component here must match the name of the user, because if it isn't, the user is trying to modify somebody else. So we can easily express that by just saying users as the first path component. As the next one must be the user name. So by that, we've fulfilled these three requirements on authorization. And as a final thing here, we can try this out again by just using OPA eval. See, in this case, we're not allowed because Joe here or Jane here should not be able to edit Joe. But if we change this to Jane, Hopefully that should work. So this is basically the basics of policy evaluation. But of course, when we work with policy, this might be a good model. But over time, we're going to want to know that this works, even if we modify the policy later, or if new data is introduced. So in order to avoid having to test this manually each time, again, OPA provides a unit test framework. So if we were to use that here, we could create another file. We call that policy test Rego. It's going to add a package here. So the unit tests are also written in Rego. It's a very simple framework. And I'm going to import the data policy allow rule. So this is the same rule here that we queried using OPA eval before. Now we're going to want to write a unit test. So if we were to write a unit test here for the first one, what we need to do then, because in the unit test, we don't really have a user asking questions. So we need to mock the input. As I'm sure is familiar to most of you, what a mock is and so on. So basically, we're going to fake a user input. So what we can do here is we say test allow access to public, or whatever we want to name it here. Names don't really matter here. Again, I don't think I mentioned that. We named the rule allow here. That was just because that was basically what the requirement was. But allow does not mean anything in Rego. Deny does not mean anything. Violation does not mean anything. These are all just common names for things that user want to evaluate. You want to know if someone is allowed or denied, but they are not keywords in any way. And you can choose to name your rules however you see fit. So in this case, I'm going to say test allow access to public, read access to public. And we're going to write a simple unit test here. And again, the anatomy here is pretty much the same as before. It's a rule followed by some conditions. So we're going to say allow if, and in this case, we're just going to say with, because we're going to have to mock some input. With input as, and now we can pretty much copy paste what we have here, but I don't think we're going to need all of that. So we're just going to do request. We're going to say method is get, path is public, and it was a list, not a string. So now we have our first unit test. We're just making an assertion that if the method is get, the path is public, we don't need to check for the name or the roles. This should be allowed. The way we can test this now is we run OPA test, and we can see that, yeah, indeed, that works. We can even run with the verbose flag if we want to see which tests are run. And we can also see that 177 microseconds, that's pretty fast. So a policy evaluation in general is very, very fast. Again, so what about the other rule then? We might want to test that. Allow anyone authenticated to read resources. And this, I'm pretty lazy, so I'm going to copy here. I'm going to paste authenticated read access to users. And in this case, we are going to need to have a user, wouldn't we? That was one of the requirements. Name, let's say Anders here, and the path we wanted to test here was, of course, users. So we have another unit test. Oh, and now we have our first failure. I don't think we need to do the verbose here. That's overtly verbose when we do when we have failures, because we get like a stack trace here. So this one failed, and why did that fail then? We had the policy said that if we have get the path is users, or the first path component is users. That should be request method is get path. Oh, sorry, there's an S too much there. Oh, so simple typo. But these kind of things happen, of course. And this is the whole like point of writing these tests, that you can build trust in what you're working with. And if there's a typo in your policy, if there's something wrong, this is precisely why you'd write this as tests. So I think I'm going to have to move back here in order so we're not going over time. But I think I hope you got a basic understanding on like policy authoring process and how we can work with tests to build trust in our policy, and to build trust in like the process over time. So admission control.
Do you want to take a couple of questions? There's actually one in the Q&A. Can you get to the Q&A, or do you need me to read?
Oh yeah, no, of course I can do that. Only reference when starting a service. Oh, that's a great question. Like, so yeah, one of the ideas here, again, is that policy is decoupled from your application logic. So when your service queries OPA, your service has no idea what policy it has loaded. And the lifecycle of OPA's policy is not connected in any way to your services. So meaning OPA can go and fetch policy and data from an external source, such as like the Styra control plane, without ever having to restart a service or anything like that. So the policy lifecycle is no longer connected to the application lifecycle. On your third policy, can you parameterize user names? Oh, you mean parameterize them for tests? Yeah, that's a good question. You can't do it like Rego is not that dynamic, like, so you can't do it sort of like these very dynamic frameworks. What are they called, like Spock and things, where you can basically build data tables and run tests on them. But you could definitely create an array of users and have that looped over in the tests. We can look more into that later if you want to reach out. Oh, well, a common use case for OPA is, of course, Kubernetes admission control. So I'm just going to go through this a bit, and we're going to see two other use cases as well. So one thing that we really need to know, like before we look into admission control, we're going to need to know, like, how does the Kubernetes API work? And I'm sure many of you are familiar with this already, but I'm just going to repeat it nonetheless. So when we have a user saying something like kubectl apply my application.yaml, because they want to deploy that or they want to modify what's there, before that change is persisted in the Kubernetes database, which is of course etcd, that request is going to have to pass a series of modules in the Kubernetes API. First off, it's authentication. We need to determine the identity of the user. Then there's an authorization step. Is the user allowed to do this? After that, we enter admission control, where we can modify or validate the actual object about to be persisted. So if you have a deployment, you could change attributes in that in the mutating admission controller, or you can validate attributes in the validating admission controller, basically saying like, this should not be allowed because this value is not secure, so on. These modules are all chainable, so you can use as many authorizers or admission controllers as you want. And of course, Kubernetes comes with a bunch of these built in, some of them more well-known than others. But what we're really interested in here is, of course, the webhook, which is an option for all of these modules. Rather than having Kubernetes do this, you can reach out to an external service, and Kubernetes will send some JSON data over an HTTP API. Does that sound familiar? Yeah, well, that's basically the model OPA works with. And I think OPA predates Kubernetes admission control by a year or two. So there's really OPA was not built for Kubernetes, and obviously Kubernetes was not built for OPA, but still it just works exactly as intended. So we're going to zoom in here on the validating admission controller. And the reason I'm going to focus on that is it's by far the most popular module to extend. The reason it is because it allows us to build policy-based guardrails around our clusters, or moat, or safety nets, or whatever you want to call them. So some common policies you'll see in the Kubernetes space or in the admission control. And as you can see here, we're no longer authorizing users. That's already done in a previous module. We're rather authorizing the objects or the resources themselves. So we might want to assert that any image in a container is pulled from an internal registry and not from just anywhere. We might want to enforce organizational requirements such as labels or annotations. So any deployed resource should have a team name on it, maybe a cost center, so on. And some other things might require knowledge about the outside world. We can't just look at the input. Like uniqueness would be an example of that. If you deploy an ingress, you might want to know that the path here, or the host in this ingress, is not already out there, because that's going to be overwritten. And that's probably not a good thing. So we might want to use the Kubernetes API as a data source for OPA before we make that decision. And a lot of other things, TLS for services, denying certain insecure attributes, host path volume mounts, might want to set limits on resource allocation, pod security policies, and so on and so forth. So basically anything you can think of as a policy, you can use OPA for that. Or you can use, again, you're not limited to using the input data either. If you want to deny Friday night deployments, or if you want to have calendar data, maybe you want to check, is there anyone on call? That's all possible with OPA. And the model, of course, I think is familiar by now, given the demo on Rego. We have some input. An input is just JSON, and we have a rule. This rule looks a little different because it builds up a set of strings rather than saying or giving a Boolean back. We have a set of strings because for these type of policies, we can normally have quite a few violations. So we'd obviously want the user to know about each of them, not just a single one. So in this case, we see that we have a rule called deny, which builds up a set of messages. And in this case, we see that if there's not a label called cost center, we send back, or we add a message to the deny list, and we send back that list. So the principle is the same, whether it's app authorization or whether it's admission control. Cloud infrastructure, of course, is another popular use case where you use OPA pretty much the same way as you would for Kubernetes. You build guardrails, but in this case, it's more around your infrastructure. So rules like prohibit instances without a VPC, maybe restrict the number of allowed machine images on instances, restrict deployments to certain regions, restrict deletion, and so on and so forth. There's also more like kind of intricate rules like cost control, where you can try and calculate costs, or even the blast radius if you want to delete resources, or if you want to make some modifications. What would be the outcome of that be? And again, things like organizational concerns like labels and so on. So while these are often about security, I'd say like these guardrails are probably more about protecting yourself or from yourself than it is from some malicious actor. Because of course, it's going to be in your interest as well that you can't do things which are like prohibitively expensive, or just it's going to cause a lot of stress and concern. So these guardrails are just as much for us as they are to protect our clusters. The authorization use case, we saw an example of policy for authorization, but and I'm not gonna go deep into the details here. I just wanted to see, like, because authorization is by far, at least from a deployment perspective, by far the more complex use case for OPA, especially given the zero trust security model, where we basically say that we trust nothing unless we verify identity and we verify permissions, and we do that at each step along the way. So it's not enough to just put a gateway in front and say, okay, we know who the user is, now it's an open highway. But we do that check at all steps along the way. So authorization, and here you can, if this were to be a Kubernetes system, you'd see OPA deployed next to each service inside the same pod using that sidecar model. But of course, there are other ways of doing this than Kube as well. And since there was a question on this before, here we can see a hint on how this would work with policy distribution. In this case, you have a control plane, which is the Styra one, but it wouldn't need to be that advanced. You could have your policies stored in an S3 bucket if you wanted to. And you'd have each service or each OPA in these services reach out periodically to see, are there any updates? And these updates would be distributed out to all the nodes. So the services have no notion of authorization or policy and whatnot. That's all managed by OPA and the central control plane. So that's basically what Styra provides. Like, OPA is the distributed component. Styra provides a centralized control plane. And along with that comes things like decision logging, knowing all the decisions that OPA made in this huge distributed environment, knowing that they are all reported back, can be audited, traced back later. So just before we're done here, and for you who are familiar with OPA since before, I figured it might be interesting to know some of the most recent additions to the policy engine and the language. So there's a couple of new keywords. There's an in keyword for checking for membership. If you're familiar with Python, it's probably familiar to you. It simplifies this quite a lot. The common way of doing this before was you'd iterate over a collection and see if there was an item in it. You can now simplify that by just saying, like, is admin in the user groups? There's a new keyword for iteration, which is called sum. And there's another one called every, which asserts that all items in a collection fulfill some predicate. There's metadata annotations, another recent feature where you can annotate the Rego rules themselves for use in tooling or beautiful docs and so on. There's an intermediate representation format, basically compiling down Rego into a very low level representation, which you can then use in languages where you traditionally would not have access to OPA, like C or so. There's a disk storage option now. Traditionally, you run OPA keeps all policy and data in memory, but if you have a lot of data, you might want to take a look at this. There's a print function, which allows you to simply, pretty much what it says it does. It just prints out values and whatnot. Function mocking, we saw some unit tests here before. There's now also the option to mock out like the built-ins of OPA and Rego, so not just your own things, but also what we provided. And there's a new introspection command connected to these metadata annotations, so you can read annotations from inside of your policy and rules as well, and a whole bunch of new built-ins. So if you haven't been in OPA land for some time, make sure to check out the release notes. So if you want to start with OPA, I suggest you start small. Maybe write a few simple policies and tests. Browse the OPA docs. Again, that's a great resource. Get a feel for the basics, the built-ins, so on. We didn't really cover the built-ins here, but OPA ships with, I think there are over 150 built-ins to work with arrays, strings, sets, and so on. So there's a good chance you'll find what you're looking for there. And once you kind of know the basics, just take a look at some application or service you worked with in the past and consider where you have policy today, because it's not like you can choose to work with policy or not. It's just if you can do it in a good way or not. So policy is going to be everywhere. So try and identify policy in your business logic and see if you can move that out into OPA. And if you can, you start delegate in small steps. Just maybe take a single endpoint and start querying OPA for only that endpoint. So you build trust in the model. Once you do, you can just scale up from there. And once you scale up, you're going to want to look into these kind of management capabilities, knowing what's going on in your cluster for monitoring, knowing the decisions taken, having remote endpoints to deploy policy and so on. That's basically what Styra DAS does. A great free resource is the Styra Academy. It's a video-based kind of learning tutorials and so on with quiz-style tests. So if the reading docs is not for you, I'd suggest you take a look at that. It's a good complementary resource. And of course, there's the OPA Slack. We're almost 6,000 users there. So I think that's it for me. I don't know if was there any questions or.
There are 3 more questions that you might want to take a look at, or 4.
Oh yeah, for sure. Should I stop the share here or?
No, well, you can leave it.
Okay, let's see here. So this extends to beyond security to business policies. Oh yeah, for sure. Definitely extends. Basically, policy is, yeah, whatever organizational policy or whatever you might want it to be. There's no, again, OPA is general purpose, so it doesn't decide for you what a policy is or should be. So OPA provides policy decision and component at cloud service or cloud service provider need to apply policy to the particular service. I'm not sure I understand that. But yeah, if we're talking about enforcement, that's correct. Like in the Kubernetes case, for example, Kubernetes sends a resource to OPA, and OPA just sends back a response. Should this be denied or not, or allowed or not? But it's then up to the Kube API to enforce that. So OPA doesn't do enforcement. Are there restrictions in OPA with regards to interrogating response data? It looks like we could have a microservice or app call OPA policies during the response processing too, correct? In healthcare, there are plenty of use cases where policies need to be applied conditionally on response data. Oh yeah, definitely. If you want to query OPA on the way back, so to speak, like that's definitely doable. I think the common model is definitely to just do it when the request comes in. There's nothing stopping you from sending another request once you know more. But of course, another way you could do it is, of course, if you provide that data to OPA beforehand, so that when the request comes in, that data is available. But obviously that's not always doable. So that model could definitely work. How large have enterprise customers grown their OPA environments? Hundreds or thousands of rules? Oh yeah, definitely in the thousands. I work mostly on the open source side of OPA, so I'm not aware of all enterprise use cases or their policies. But yeah, I've definitely seen thousands of rules. Or is this stretching it too far into data privacy? Oh, okay, that was related to the healthcare. No, I don't think that's stretching it too far. I think privacy is definitely something like bound by policy. So I think privacy in any type of regulations like GDPR and so on. It's definitely a good target for policy. How secure is the implementation? Can I send large data or data that causes a regex dose to OPA and starve resources? That's a good question. I'd suggest you try. I think, however, the common model, you'd commonly run OPA in an environment such as the sidecar model. OPA is not exposed to the public. It's only exposed on localhost to the other service running on the same port or on the same host. So in the normal case, you trust that client not to try that. But of course, you can run a OPA publicly as well. You can require authentication, authorization, and so on. But it's not common that you'll find like a publicly exposed OPA that just anyone can send anything into. But yeah, for sure, if there are exploits like that, we'd love to find and fix them. For the Kubernetes use case, how OPA compared to Kubernetes? Yeah, that's another good question. So Kubernetes is another policy engine, which basically, I think, tries to mimic the Kubernetes model by even specifying your policies in YAML, since pretty much everything in Kube is YAML. It doesn't really, it breaks down eventually when you need to define certain things like loops and so on. So it's not like pure YAML, but there's some logic embedded in their values there as well. It's basically just another policy language embedded in YAML. And I think it's a fine policy engine. I don't have any, like, I'm not gonna criticize that here, but I think like philosophically, they are very far from what OPA does, given like all these wide range of use cases. Because that's the thing, like you can learn Kubernetes and you can deploy that to your cluster, but that knowledge is useless for authorization. It's useless for Terraform or infrastructure. It's a single purpose policy engine. So, and of course, if you have a single purpose, why not? But I think that's the real draw of OPA, is that you can take that knowledge and you can apply that all across the stack. So I think like there's a huge philosophical difference there. Can OPA be used for policy management for infrastructure, like storage, compute? Oh yeah, for sure. I'm not sure like at what stage we're referring to here, but you'd commonly use that, such as in the Terraform case, where you create a plan, turn that plan file into JSON, and then you provide that as input to OPA as any other data. So like whether it's infrastructure, whether it's this, like OPA doesn't really care. It's just data to OPA.
Thank you, Anders. I had one more comment, which is that I heard about OPA for in combination with spiff Aspire for authentication. Is this a good combination for?
Oh yeah, for sure. I think like spiff Aspire is an amazing project, and I know we have worked with them in the past, and I know there's an OPA integration kind of built into the project. I've not had the time yet to kind of play around with it myself, so I can't speak for the quality of that, but like knowing the rest of that project is, I'm confident to say that it's going to be great.
Okay, thank you very much. Thanks everyone for answering the poll, and thanks Anders for this really interesting session. Very well explained, good demo. Thanks everyone for joining, and we'll talk to you next month. Thank you everyone. Bye-bye.
Thanks everyone.